Okay, so I was looking at a question some time ago, and I came across this one, which said that uh, we have a function, well, a group of functions which are a part of the set, and when differentiated, each of them equal to 2x times the original function. So they gave us an example which said that f of x, let's say it's e to the x squared, then f prime of x would be 2x times e to the x squared, which makes sense because when you differentiate this, you get 2x and then it comes down. So when and they gave us another example which basically was like it's not a part of w, uh, which is sine x, and when it's differentiated, it gives cos x, which is not 2x times the initial, which is sine x. So this would not be true, which makes it not a part of the thing. So we have to prove that W is a subspace of this set. And we have already been given one complete function that follows this rule, so we do not need to prove that the set is not an empty set. But we can still try to prove that it's not an empty set by taking the zero vector. So when we let fx be 0 and we take its derivative, we get 2x times the initial, which is 0, which would be 0, which makes sense when we follow this. So this is right, and we get the zero vector to be in this set. When we look at vector addition, we have W1 and W2, which are both belong to W. And W1 is a function when differentiated, it gives 2x times W1, same with W2. And we are trying to find if when we do vector addition of W1 and W2, does the third vector, W3, also follow the same rule? Meaning, does it also have 2x times W3? So we have W1 and W2, and we derive all three of them, and we find out that W3, the derivative of W3 is W1, the derivative of W1 plus the derivative of W2. And 2x times W1, well, we know what these derivatives are because we bring them from here, and we say that 2x times W1 plus 2x times W2 is W3's derivative. And then we can factor out 2x, making it 2x times W1 plus W2, and we know what this is from here, which is W3. So it follows that. So it follows the zero vector rule and the vector addition rule. Now scalar multiplication. So we have W2, which is again the same thing as before, but in this one it's equal to a different function, kind of making a chain rule. Not really, but this is a constant alpha, and we're multiplying it with a function, and we know that this function follows W, so we know that W1 belongs to W, and we want to find out that if W2 belongs to W, right? So this is an entire test. This is another check proving that. So we take the derivative of W2, and we get alpha times W1 and the entire derivative of that. And we know that we can just bring this out because it's multiplied by a function, just like how 2x, when we derive it, we don't really change 2. It's the same way because this is also a constant. Uh, and then we get this because we know what the derivative of W1 is. And we're basically saying that is our answer equal to the derivative of W2, and the derivative of W2 would be 2x times the initial, which is 2x times alpha times W1. And we know that this is 2x times alpha times W1. We just need to reconfigure this, making taking 2x outside and alpha inside, and we get 2x times alpha times W1, which is again 2x times w2, which matches. So that's how you do the subspace, the function being a part of a function being a subspace of a set. Uh, I'm tired by talking, but yeah, function being a subspace of a set using these three checks.